Hi, welcome to the Olympiad geometry. Let's continue our study on radical axis. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Thank you. Here is a problem in triangle ABC. O is circumcenter, H is orthocenter, AD, B, E, C, F are altitudes. Line ED meets AB on M. Line FD meets AC on N. Prove OB is perpendicular with DF. OC is perpendicular with DE. OA is perpendicular with FE. OH is perpendicular with MN. So for this problem, we can see that for the first three, right, OB is perpendicular with DF, OC is perpendicular with DE, OA is perpendicular with HF. We can just prove one of them, and the other two are obvious if we can prove the first one, right? Let's see, we want to prove OB is perpendicular with DF. OB is here, DF is here. Let's connect OA. So we know that angle BOA equals to twice of angle BCA, right? Then we can do OM, find the midpoint of AB, right? We already know that OB equals to OA, so OM is perpendicular with AB. OM is perpendicular with AB. So angle BOM equals to angle BCA, right? And because this is 90 degrees, the angle ADC is 90 degrees, the angle OMB is 90 degrees. So we know that angle OBM equals to angle DAC, right? OBM equals to DAC. And because angle ADC is 90 degrees, angle CFA is 90 degrees, so we know that ACDF are cyclic. Right. So we know that angle DAC equals to angle DFC. Right. Angle DAC equals to angle DFC equals to this angle. And actually, because angle DAC equals to angle CBE, and angle CBE equals to angle, and because AEB, DB are cyclic, so this angle, the angle CBE also equals to angle CAD equals to angle EFC, right? But it doesn't matter for proving OB to be perpendicular with DF. I just want to mention that we actually already proved this before, that these two angles are equal, right? Okay, so angle DAC equals to angle DFC, right? And we already proved that angle DAC equals to angle OBM. So we know that angle OBM equals to angle DFC, right? So OBM equals to angle DFC equals to this one. Okay, now we extend OB. Okay, we extend OB. And let's call this intersection point, that OB extension to FD. Let's call it, oh, I call this, sorry, let's say it's P, right? You know, we have all of these m should be this m, not this m, right? So here, I mean the angle BOP. This is P, and this is P, right? And OP. We were talking about this part. We didn't talk about the MN part, right? So all the M I written before is actually point to P. I'm sorry for the confusion here. So let me just rephrase. The angle OBP equals to angle CFD, right? And now we set this point, let's call it G. So because angle DFC plus angle DFB equals to 90 degree, right? Angle DFC plus angle DFB equals to 90 degree. And we know that angle DFC equals to angle OBP. So angle OBP plus angle DFB equals to 90 degree, right? OBP, this angle, plus angle DFB or DFP equals to 90 degree, which means that angle BGF equals to 90 degree. So OB is perpendicular with DF, right? Similarly, the OC is perpendicular with DE and OA is perpendicular with EF. Okay, that's the first part. For the second part, that we want to prove OH is perpendicular with MN. Let's just look at how we get M, right? M comes from the extension of DE and BA. N comes from extension of AC and FD, right? If we just look at DEAB, that extension, we notice that actually DEAB are cyclic, right? And for the extension of the AC and FD, ACFD meets at N, and we know that ACDF are cyclic. So this gives us a hint that we can directly write down that MA times MB equals to ME times MD, right? And also we know that NC times NA equals to ND times NF. Right? So MA times MB equals to ME times MB, right? This equation is because that AEDB are cyclic. Right? And this one, NC times NA equals to ND times NF. NC times NA equals to ND times NF is because that ACDF are cyclic. Right? And think about that, we want to prove OH to be perpendicular with MN. Right? MA times MB is the power of M to circle O. Right? And NC times NA is the power of N to the circle O. So it means that if we can prove the right part of this stuff is also actually ME times MD and ND times NF are also the power to another certain, the power of Mn to another certain circle, which has a center on the line OH. Then we can say that Mn is the radical axis of these two circles, right? And we know that OH would be perpendicular with Mn. So we're looking for that circle, right? Look at here. That circle is actually obvious because we want to have ME times MD means that E is on the circle, D is on the circle, and ND times NF means D is on the circle, F is on the circle, which means that we are looking for the circumcircle of triangle FDE, right? Circumcircle of the triangle FDE. So if you remember it, that's a 9-point circle, right? Because FDE are the foot of altitudes on 3 edges, right? The circumcircle of triangle FDE is the 9-point circle. And for the 9-point circle, we already proved that the center of the 9-point circle is the midpoint of OH, right? We used to mark it as the circle V. So circle V is a 9-point circle, and V is midpoint of OH. Right. Okay, now let's just look at the circle, 9-point circle. I just draw it here. Right. Look at this 9-point circle, which has a center V at the midpoint of OH, right? So look at the circle V and circle O. We know that MA times MB, right? MA times MB, that's the power of M to circle O equals to ME times MD, right? ME times MD, that's a power of M to circle V, right? So this is true. Means that M is on the radical axis of circle O and circle V, right? And for N point, that NC times NA is actually the power of N, the power of point N to the circle O, right? And it equals to ND times NF, and ND times NF is the power of N to the circle V, right? Which means they are equal, means that N is on the radical axis of circle O and circle V, right? Which means that MN is radical axis of circle O and circle V, right? And we already know that V is on the OH, means that OV is a center connection line, right? OH is a center connection line, and we know that center connection line is always perpendicular with the radical axis, so OH is perpendicular with MN. Okay, so for this problem, we start with proving that OB is perpendicular with DF, which is purely simple. I would say it's very straightforward because we can just find the angle equivalent and directly prove it. But for the OH is perpendicular with MN, we need to check out how we get M and N, right? And based on that, we can have the equations here. And these equations actually give us a hint that we can use the radical axis to do the perpendicular relationship provement, right? So then we, for the left part of the equations, we notice that they are the power of 2 points to the circle O. So for the right side of the equation, we just need to find which circle it might be, right? And it's very straightforward once we find that it's the DEF are on this circle, then it's a 9-point circle. And for the 9-point circle, we already learn a lot, especially that V is the midpoint of the OH and V is the center of the 9-point circle. So everything becomes straightforward then, right? Basically, this is a problem that you need more knowledge than, I would say more knowledge than analysis, because this analysis is kind of, once you notice that, it's kind of straightforward, but the knowledge of the 9-point circle is a foundation to solve this problem. Okay, I hope you like this video. See you in next one. Thank you.